Hey guys, for today's lab, you're gonna need some different supplies. You've got the printout here, and you don't really need all the materials exactly like they talk about, but for the first one, I'm just gonna flip it over. That's kind of 1 through 6. This is doing half-lives. We're gonna simulate it with pennies. Now, inside my box, I've got my 100 pennies, all meticulously facing face up. All the tails are down. So just as it reads, place 100 pennies in the box. Doesn't have to be a shoe box, but they're easy to get. We're using these little plastic boxes, which I have here. And then it says, we're going to record them unchanged in there and changed. So obviously they're all heads up. Those would be the unchanged atoms. Anything that winds up being tails up are the changed. We're looking at half-lives. 100 pennies, we're gonna shake and see what happens. With a lid on the box, shake the box up and down 5 times. We just want to make sure we get a random assortment, and then we're going to count each one. Open the lid, we'll remove the pennies and go. So let's just run through one option. Now, you don't have pennies, I don't know, Pokemon chips. You need 100 of something. It doesn't necessarily have to be pennies. Any amount of change would do, but not 100 cents worth. You need 100 items. Most of us have kind of like change jar laying around. You need 100 coins, something that's going to be heads and tails. If they're all pennies, we're talking all the same material. The odds of them flipping are a little better. If you don't have 100 pennies, 50 pennies, 5 quarters, 10 dollars, whatever you got. Try and get up with 100 pennies, scrounge around, go to the store and see if they'll sell you pennies. But anyway, 100 pennies. Here we go. Let's do it one time. Put my lid on. Wow. All right. Now I'm going to go through here and I got to remove all the ones that have changed. Tail, 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 tail. I'm not going to do it. That's your job. But you get the idea. I'm going to pull them all out and then I'm going to count what's left. And just as the instructions say, we're going to go through. I'm going to count the number. I'm going to record it in there, but record the number in the row. Each lab partner should predict how many times steps 2 through 4 will need to be repeated until only one unchanged atom remains. What do you think it's going to take? We did it once. You pull it out. How many? How many times do you think we'll go through it till we have 1 penny left unchanged, only 1 head? You're going to have to run the experiment and find out what it is. Make your prediction and then run through. You get the idea. Pull them out, shake, shake, shake. Anything that's not heads is unchanged and we remove it. We're simulating half-lives because it's random, right? We don't know which atoms are going to change or not, which ones are going to get off a bit of alpha decay, shoot neutrons out of their particles, and we're no longer left with uranium, we're left with other atoms because their atoms have changed. Run through the lab. That's how you do the first part of it. I'll come back at you a second, show the materials you need to run section B, and you're good to go. All right, guys, for this part of the experiment, the setup reads a little funny, but it's no more different than this. What we're gonna do here in class, we're just gonna turn the lab tables into a grid. So it talks about doing it on poster board. You could do it on your table or something else, but here's your basic setup. So you can get a big piece of paper, poster board. It'd be hard to do it on a regular piece of paper, but possible. But you know, work with your table, something you get. Amount of material over here, you don't have to print out a sign. I have the numbers out 1 through 8. It says put them 10 centimeters apart. You just need to space them evenly. Our table doesn't really work for a nice neat. Ours is gonna be about 17 centimeters apart. So this is your basic setup. Time, amount of material. You need 2 longish strips of material and we're gonna do half-lives. Now I'm just gonna show you how to get it started. You need to run the whole thing out for yourself, take a look at what happens, run your string graph. You don't even have to do the piece of string. they're just trying to turn it into a line graph. You can probably eyeball it and get your data, but by all means, use a string. If you do it on a piece of paper, you can just turn your bar graph into a line graph. Not that big of a deal. Let's take a look. So we have two pieces of paper that are equal in size. Well, here is one. Well, after a half-life, there'll only be half as much of the material, right? So we're just going to fold it in half, cut it in half, and there's my first half-life. What do I do for the next half-life? Well, after 3 minutes, I have a half. I'm not going to put it down. I'll put that one. I cut this one in half, and so on. And we're going to go through 8 minutes, if you will, of half-life. Now, normally a half-life is a lot longer than a minute, but, you know, in our mysterious 1 minute half-life radioactive material, you're going to plot it out, take a look, answer your questions. All right, take care, and we'll see you next time.